Hello guys, in this video I'm going to be solving this Pure Mathematics paper 1 from February-March 2025. So I would strongly recommend that you grab a piece of paper and your calculator and we solve this together. Right? So let's start. So the first question on this paper is saying a curve has the equation y equals 5 plus 3x minus 2x squared, and the straight line is equation y equals kx plus 13, where k is a constant. Find the set of values of k for which the curve and the line do not meet. Right? And so for this one, we're going to try and get one equation out of these two that we're given. Then we go on and use the discriminant, right? So we know that y is always equal to y, so we can then equate these two expressions, right? So 5, we can write y is equal to y, right? So 5 plus 3x minus 2x squared should be equal to kx plus 13, right? Then we group like terms, right? But for this particular question, I'm going to try and get everything to the right hand side, right? So that will give us a positive 2x squared plus kx minus 3x plus 13 minus 5 equal to 0, like this, right? And simplifying this further, we get 2x squared plus kx minus 3x plus 8 equaling to 0, like that. Now with this quadratic equation, we can go ahead and use the discriminant, right? We know that if these two do not meet, then the discriminant, which is b squared minus 4ac, should be less than 0, right? And for discriminant, we need to know what our a is, our b, and our c, right? And for a, it's straightforward. It's the coefficient of x squared. So our a is 2. But for our b now, we need to factor out x here, because our b is the coefficient of x, right? So factoring out x there, we can see that it will be x, right, k minus 3, like that. So k minus 3 will be our b, k minus 3, right? And our c will be straightforward, that's our 8, right? Now putting these in our discriminant here, we get k minus 3 squared minus 4, our a, which is 2, then our c, which is 8, right? Like this, right? But this time we want to put an equal sign, right, as opposed to this one, because we want to find the critical values, right? The critical values or the critical points. So with this now we have k minus 3 squared minus 64 being equal to 0, right? Taking the 64 to the other side, we get k minus 3 squared being equal to 64, right? And at this point, we introduce square root to both sides, right? And this will give us k minus 3 being equal to plus or minus 8, right? And taking the 3 to that side, it will be k equal to plus or minus 8 plus 3. So our two values of k will be 8 plus 3, which is 11, or minus 8 plus 3, which is minus 5. And these are our critical values, right? And we're going to go ahead and use the graphical method, right, to find the set of values because these are just two values, but we are asked to find the set of values of k for which the curve and the line do not meet. So to get that set of values, we're going to use the graphical method. So we just draw a little sketch, our y and our x, right? Then we take this to be our k in this case, right? Because it's k here. So taking that to be our k, we have minus 5 and 11 like this, right? And if we come up here, we can see that the coefficient of x squared was positive, right? Meaning that the parabola will be facing upwards like this, right? Now with this, we consider this side. We're back to our discriminant. We said b squared minus 4ac should be less than 0 for the curve and the line not to meet, right? So if there is a less than, it means we are dealing with this region that is beneath the k-axis in this case, right? This region that is below the horizontal axis, like that, right? And we can see that for us to get a region where we have this, it's from minus 5 to 11, right? So writing that down, we just put it like this, right? Because we're going from minus 5 through to 11, right? For us to get this region that is below the horizontal axis, and that will be our region, or the set of values of k for which the curve and the line do not meet, right? If the question was saying for which the curve and the line meet, right, we would have used b squared minus 4ac greater than 0. And for that, if we have a greater than, it means we'll be dealing with the region above the horizontal axis, which is that. So in that case, the set of values would be k less than minus 5 and k greater than 11. K is less than 5 and k being greater than 11 for that particular case. But for this question, we're going from minus 5 to 11, right? So moving on to the second question, number 2, is saying the diagram shows the curve with the equation y equals 2x squared minus 5 over x plus 3. The curve crosses the x-axis at the point P, which is 1, 0, yeah, and M is a minimum point. You can see M here, and we're being told that it's a minimum point, right? Then for part A, it's saying find the gradient of the curve at P, right? So we are given the equation of the curve right here, but we're being asked to get the gradient of the curve at P. And we know for us to get the gradient, we just need to get the derivative of this, right, which is our dy dx. So our dy dx will be these two multiplying this, which will give us 4. Then we put our x, we subtract 1 from that power, that will be x to the power 1, right? And we know this is minus 5x to the power minus 1, right? So multiplying this minus 1 and this minus 5, we get a positive 5, right? But we subtract 1 from the power. Here we had minus 1, so subtracting 1, it will be x to the power minus 2, which is 5 over x squared, like this, right? Then with this now, we want the gradient of the curve at point P, right? and we know at point P we have 1 0 as the coordinates of P, so it means that at P our x is 1, so we're going to substitute 1 and this derivative right here, so that would be 4 1 plus 5 over 1 squared, right? So that's 4 plus 5, which gives us 9, right? So the gradient of the curve at P is 9. You might be wondering why I did not talk about this 3 right here, but I'm assuming that you know that if we differentiate a constant or a number, we get 0, so there's no point in writing that, right? And for B, says find the coordinates of M and give each coordinate correct to 3 significant figures. We know M is a minimum point. We're told M is a minimum point. So what do we know about minimum points? We know that at minimum points, the gradient is 0, right? So in other words, at minimum point or at minimum points, dy dx is 0, right? So we're going to get dy dx, which is this expression, 4x plus 5 over x squared. Then we're going to equate it to 0, right? Because we know M is a minimum point. So dy dx should be equal to 0 at that point. And this is going to give us the x value of M, right? So in trying to solve this, we're going to first multiply everything by x squared, right? And this will give us 4x to the power 3 plus 5 being equal to 0, like that, right? And taking that 5 to the other side to be minus 5, so 4x to the power 3 is equal to minus 5, right? And so we divide both sides by 4, and this will give us x to the power 3 is equal to minus 5 over 4, right? And to get x from what we have to introduce or raise everything to the power 1 over 3, right? So this will give us x equal to minus 5 over 4 to the power a third, right? So that will be minus 5 over 4 to the power 1 over 3. That's x equals to minus 1,0772, right? That's our x right there. And so let me just make a bit of space down here. Right. And so for us to get the y coordinate, we just have to substitute this x value that we got into the original equation, right? And so in doing that, we can store this value in our calculators, right? Then substitute it for x there. So it's 2, then our stored value squared minus 5 over stored value plus 3, right? And that came out as y being equal to 9.962, right? So if we look at the question here, it says give each coordinate, meaning the x and the y coordinates, give each coordinate correct to 3 significant figures. So this correct to 3 significant figures will be minus 1 comma 0 8, right? And this one will be 9.96, right? And this will be the coordinate of M. Then you get your 3 marks for that, right? And for number 3, part A says find the complete expansion of 2x minus 3 over x to the power 4. So that's a bit of a binomial expansion there. And just by looking at this, we can tell that it has 5 terms by seeing this 4 here, because we get the first term after choosing 0 from 4. So to get the complete expansion, we start with the first one. That's our 4 choose 0 multiplied by minus 3. Would like to start with this one, with a fraction, over x to the power 0 and 2x to the power this 4 minus this 0, that's 4, right? And for the second one, we say 4 choose 1, then minus 3 over x to the power 1, then 2x to the power 4 minus 1, which is 3, right? And this will be followed by 4 choose 2 being multiplied by minus 3 over x to the power 2, and 2x to the power 4 minus 2, which is 2. Then we add this 2, 4 choose 3, then you say minus 3 over x to the power 3, then 2x to the power 4 minus 3, that's 1. Then for the last term, that's 4 choose 4, right? Then minus 3 over x to the power 4, and 2x to the power 4 minus 4, which is 0, right? We can't go on from here because we can't choose 5 from 4, right? So we're just left with simplifying this, right? So for the first one, it's our 4 choose 0. Then for this, which is to the power 0, we know anything to the power 0 is 1. So that's like 4 choose 0 times 1 being multiplied by 2 to the power 4, right? Then we get our 16x to the power 4, right? This x is being raised to the power 4, and the 2 is being raised to the power 4 as well, right? And for the second one, we have 4 choose 1 times minus 3 times 2 to the power 3, that's our 8, which gives us minus 96x, this x to the power 3 over this x right here, right? And this will result in x squared, right? So it's 16x to the 4 minus 96x squared, right? And for the next one, it's 4 choose 2 times our minus 3 squared, that's our 9, right? Times our 2 squared, that's our 4. So we're getting plus 216, but you know that this x is being raised to the power 2, so that's this x squared over x squared, and these will cancel out like that to leave us with just the 216, right? Then for the fourth one, we're now saying 4 choose 3 times minus 3 to the power 3 times 2, right? And it's giving us minus 216. So we have minus 216, right? But we have x to the power 3 in the denominator here, x to the power 3 and x to the power 1 in the numerator, right? So that is going to leave us with x squared in the denominator there, right? X squared, like this, right? And for the last term, we have 4, choose 4, right, times minus 3, choose 4, times 1, because this to the power 0 is 1, right? And that's giving us minus 81, right? So minus 81 over x to the power 4, right? Right, so you can write this without brackets, and it will be 16 times 16x to the power 4 minus 96x squared plus 216 minus 216 over x squared minus 81 over x to the power 4, right? And our part B is saying, hence determine the coefficient of x squared in the expansion of x squared plus 5 in brackets 2x minus 3 over x to the power 4, right? And we know that we're going to need our answer from the previous question because they said hence right here, right? And so to determine the coefficient of x squared for this whole thing, let's try and look at it this way. I'm going to do the longer method here. So you can see that this is multiplying this to the power 4, but we've worked with 2x minus 3 over x to the power 4 here, right, when we were finding the complete expansion, right? So we can write this as x squared plus 5 multiplying the whole expansion, which is our 16x to the power 4 minus 96 x squared plus 216 plus let's just put minus there, minus 216 over x squared minus 81 over x to the power 4, like this, right? And from this whole thing, we're going to fish out x squared, terms in x squared, right? And we can get those by first multiplying. We know that if we're to expand this, we're going to multiply everything in the second bracket by x squared first, then we add 2 when we multiply everything by 5, just like when we're expanding x plus 2 and x minus 3. We say x times x, then x times this, then 2 times this, and 2 times this. That's the same here, right? So we're using the same concept, right? So we can see that if we say x squared times this, we won't get anything in x squared. If we say x squared times this, we won't get anything in x squared. But if we say x squared times 216, we'll get 216x squared, right? I've written it down because we're looking for terms in x squared, right? But if we say x squared times minus 216 over x squared, we won't get x squared. X squared times this last term, we won't get x squared. So this is the only x squared term that we get after multiplying this by x squared. So we move on to multiplying it by 5. So if we say 5 multiply this, we don't get a term in x squared. But if we say 5 times minus 96, we get minus 480x squared, right? And we can see that there is no other way we are going to get a term in x squared if we multiply after multiplying 5 and these two terms. So these are the only two terms in x squared that we get for this expansion, right? So for us to determine the coefficient of x squared for the whole thing, we're like factoring out x squared basically, right? So x squared will be 216, right, minus 480, like this, right? And this will be, so 216 minus 480, right? So it's minus 264x squared, right? So the coefficient of x squared for that is minus 264, right? For 2 marks, right? And so with that, we move on to number 4, which is saying the diagram shows a triangle OAB where OA is equal to OB, which is equal to 10 centimeters, and the angle AOB is 0.8 radians. Point C and D on OA and OB respectively are such that the arc CD is part of a circle with center O and radius 6 centimeters. The shaded region is bounded by the arc CD and the line segment CA, AB, and BD, right? And the first question is saying, so part A is saying, find the perimeter of the shaded region, right? In other words, we're being asked to find the distance right around the shaded region, which is our DC, CA, AB, and BD, right? And AC is 4 and BD is also 4, so we're only left with finding CD and AB, right? CD. So we can see that for CD is an arc, right, of this, right, with center O, right? So there's a circle like this, and we only shown a part of it like that. And we know for arc length, we can simply say r theta, right, with our theta and our calculators in radians, right, to get CD. And the r is the radius of the circle that we'll be dealing with, which in this case is 6. So we have 4 for AC plus our 6, the theta 0.8 radians. So it's 6 times 0.8 plus our 4 for BD. Going to subtract 0.8 radians from pi. So it gave us 2.341, right, radians. And we're going to divide this by 2 for these two angles. So that will be 1.171, right, for each one of these two angles, right? Now with that, we know that if we have a triangle like this, let's call it ABC, right, X and Y. So y over sine C should be equal to x over sine the angle at A, right? X over sine the angle at A, and C, and y over sine C, like that, right? And in our case, we're going to say 0.8 x, we call this ABX, or we can just call it AB like that. So AB over sine 0.8 radians, AB over sine 0.8. So saying AB over sine 0.8 should be equal to 10 over sine 1.171, right? Now multiplying both sides by sine 0.8, we get our AB to be 10 over sine 1.171 times sine 0.8. That gives us 7.788 as our AB, right? And plugging this value here, we'll get that plus 4 plus 6 times 0.8 plus 4, right? And that will sum up to 20.6 centimeters, right? And you get your 3 marks. And for part B, saying find the area of the shaded region. Find the area of the shaded region. I might need that. Oops. So for us to get the area of the shaded region, we can say area of the whole thing minus the area of the unshaded, right? So let's try that and see if it works. Area of whole shape minus area of the unshaded, right? So for area of the whole shape, we can see it's a triangle, so we can use half AB sine theta. A and B will be these two sides making the angle that we want to use here, right? So that will be our half 10 squared, because it's 10 times 10, which is 100, right? Sine 0.8 minus area of the unshaded. So this area of a sector, which is half r squared theta, like that, right? And we know our r is 6 for this small sector right here, so that will be our half 6 squared, that's 36, and our theta is 0.8, right? So this will give us 50 sine 0.8 minus 18 times 0.8, and this is giving us 21.5 square centimeters for area like that, right? And that will be the area for the shaded region, right? And number 5 is saying an arithmetic progression is first term 5 and common difference 6, right? So the first term, which is our a, is 5 and our common difference d is 6. A is 5 and d is 6, right? And it goes on to say, for this progression, find the sum of all the terms that lie between 150 and 400, right? So we're being asked to find the sum of all the terms that are between 150 and 400. So we can see that this question is 6 marks, so we're going to work it out in stages, right? And we can also see that we're going to be dealing with sum, right? And for us to be able to get the sums, we need n values, right? And you can also see that we are given these two, right? But we don't know the n values, right? Or the n values that will give us 150 or 400. So we need to get those n values first. Then we can work through it backwards from the sums going down, right? So we need to first get the n value that gives us 150, right? So by that we have to say a plus n minus 1, right, is equal to 150, right? Want to know the n value of the term that gives us 150, right? And we know a is our 5, so 5 plus n minus 1 is 150, right? So it's n minus 1 d, oops, my bad. So it's n minus 1 d, or d is 6, So 5 plus 6n minus 6 is equal to 150. 6n is equal to 149, because that's 150. Wait, 150 plus 6, that's 156 minus 5. 156 minus 5, that's 151, right? And dividing both sides by 6, we get our n to be 151.6, 25.166, right? And we're going to use the same method to get the n value that gives us 400. So a plus our n minus 1 d to get 400. So this would be our 5 plus 6n minus 6 is now equal to 400, right? So that's our 6n being equal to 406 minus 5, which is 401 divided by 6. So n will be 401 divided by 6. That's 66.83, like that, right? Just 1 3, yeah. Even here it was 1 6, like this. So these are the two n values that we are getting, right? So we're going to first get the sum of the first 66.83 terms, right? And we're going to subtract the answer we get from that. We're going to subtract the answer we get after we say this, after we use this n with this one, right? So we're going to get sum of first 66.8 terms, then we get sum of first 25.16 terms, then we subtract the two, right? But we also need to bear in mind that our n values can only be whole numbers. So for this 25.16, we have to round it down and use 25. Or since it's slightly above 25, we can use 26 instead. So for this, we'll use 26. And for this one, we use 67. Right, as our n values. And using 67, we know sum of 67 terms, that's half our n, which is 67, plus our 2a, that's 2 times 5, 10, plus n minus 1, that's our 67 minus 1, so that's 66 times our d, which is 6, right? And all this is in a bracket, so it's half n. Then we have 2a like that. This is in a bracket because the formula is what? Half n 2a plus n minus 1 d, like that, right? And this will give us half 67 and 10 plus 66 times 6, that's 13,601, right? That's the sum of the first 67, right? And the sum of the first 26, that will be our half. We now have 26 terms. Then our 2a, that's 10 plus 26 minus 1, 25 times our d, which is 6. And this will give us 13, 10 plus 25, 6. That's 20, 28, 7, right? And subtracting these two, we get 13,601 minus 2080. That's our 11,521, right? So the sum of all the terms that lie between 150 and 400 is 11,521, right? So we first had to get the n values. That will give one that will give us 150 and the other one that gives us 400. And we got them to be decimals and we had to use whole numbers instead, right? So we used 26 here because this is slightly above 25, so 26 would make more sense, right? Because if we had used 25, we would have left 0.16, right? So 26 makes more sense. And for this one, use 67 because it makes more sense. If we round it, we get 67, and if we use 67, we would have covered the number that we're given, right? Then you follow that to get 11,521 for 6 marks, right? And for the sixth question, it's saying the diagram shows a circle C of radius r where x is greater than 0 and y is greater than 0 for all points on C. So for all the points on the circle, x is greater than 0 and y is also greater than 0. The least distance between any point on C, meaning any point on the circle, and the x-axis is 8 units, right? The least distance between any point on the circle and the x-axis, that will be the distance that gives us 90 degrees, right? So to be like that, right? That's the least distance, right? The one that gives us 90 degrees here, right? Like that. So we're told that's 8 units, right? And the least distance between any point on C and y-axis is 5 units. So again, looking for a line that can give us 90 degrees, and that should be here, right? That will get a 90 degree here. So that will be the least distance, right? The perpendicular distance. So we're told this is 5, right? Like that. And part A is saying state the coordinates of the center of the circle in terms of r, right? R is the radius of the circle, right? For 1 mark. So I might want to extend these two. If this line is hitting the circle at 90 degrees, from my observation, I think it hits the center, right? And this one, I think it also hits the center like that, right? So if we were to get the coordinate of the center here, it will be this and this, right? So this will be the x coordinate and this will be the y, right? And we know the radius is r, right? So writing our x coordinate will be 5 plus r, because we're moving 5 plus r units in the x-axis, and in the y we're moving 8 plus r units, right? 8 units plus r units to get to that. So this will be the coordinate of the center for 1 mark. So 5 plus r and 8 plus r, like that, right? And B, given that the distance between the origin and the center of the circle is 15 units, find the value of r. So we're now told that the distance between the origin, which is O, and the center of the circle which is this, is 15, like that, right? And you can see that this length is also equal to this one right here, right? And this is equal to this. I'm not sure if you need that, but let's see. So it says find the value of r. We have 15 there. You can see that this is a right angle triangle, right? It's a right angle triangle. So if we're sure that this is a right angle triangle, the hypotenuse, which is 15, it should satisfy 15 squared equal to 5 plus r, which is this side. 5 plus r squared plus the other side, which is 8 plus r squared. Remember the Pythagoras theorem, c squared equals a squared plus b squared, right? So now simplifying that, we get our 15 squared should be 225 being equal to 25 plus 10r plus r squared plus 64 plus 16r plus r squared, right? So we're now left with collecting like terms. So dealing with the right hand side, we get 2r squared plus 26r plus 25 plus 64 plus our 89, right? And of course we have 225 on the left hand side, so like this, right? So this will be 2r squared plus 26r plus 89 minus 225, that's minus 136 equals 0. And to get r, we're going to use the quadratic formula, right? Minus b plus or minus root of b squared minus 4ac over 2a. Right, we know our b is 26, so that's minus 26 plus or minus root of 26 squared minus 4. Our a is 2 and our c is minus 136, and all this is over 2a, which is 2 by 2. So this gives us two values of r. So that will be minus 26 plus root of 26 squared minus 4, 2 minus 136 over 4. So that's 4. And the other one, you say minus 26 minus. Right. So that's minus 17. Like that, right? Then we have minus 17 like that. But it says find the value, right? Not the values, the value. And if we take 4, we get 9. 5 plus 4, that's 9 for center, and 8 plus 4, that's 12. But if we use minus 17 there, we'll end up getting values that are less than 0. Right? We're told that for all the values, that for all the x values and the y values on C, they should be more than 0. So for that reason, we're going to discard this and take r to be 4, right? And moving on to part C, which says the point on the circle furthest from the origin is denoted by P. The point on the circle furthest from the origin. So the point that will be furthest from the origin will be this point. Use a different color. Get back to black. And after that, they said find the gradient of the tangent to the circle at P. Find the gradient of the tangent of the circle at P. That's the same as saying find the gradient of the circle at P, but we know that this line is a tangent and it meets R at 90 degrees. So if we can get the gradient of this line that goes from the origin all the way to P, we can then say the negative reciprocal of that, right? The negative reciprocal of that. Then we multiply by that to get the gradient of this line. Because for two lines that are perpendicular to each other, we know that m1 times m2 should give us -1, right? So we're going to try and get this. And we know that our r is 4, right? Our r is 4. So this right here will be 8 plus 4, which is 12, right? 12 right there. So our change in y will be our 12 over our change in x, which is our 5 plus r, which is 9, right? So that's our 12 over 9, and that is giving us 4 over 3. So if the gradient of this line, which is this, is 4 over 3, and we're being asked to get the gradient of the line that is perpendicular, we're going to say this 4 over 3 times the gradient of the line that's perpendicular should give us -1, and our m2 straight away be -3 over 4, right? That's why it has 2 marks. Yes, and you get your 2 marks for that, right? And for number 7, it says show that 3 tan squared theta plus 5 sine squared theta is identical to 8 sine squared theta minus 5 sine to the power 4 theta over 1 minus sine squared theta. Alright, and to prove this, we are going to use the left hand side, because we can expand this to get that, right? So using the left hand side, which is 3 tan squared theta plus 5 sine squared theta, we're going to write tan in terms of sine and cos. So tan squared will be sine squared theta over cos squared theta, right? And we're adding 5 sine squared theta, and we know this is over 1, right? So our common denominator for this, since we can see that for this one on the right hand side we have one fraction, so to make this one fraction we need the common denominator, which is cos squared theta, right? So this will be 3 sine squared theta, but this will be cos squared theta, then 5 sine squared theta, like this, right? But we know that cos squared theta can be written as 1 minus sine squared theta, right? So this will be 3 sine squared theta plus 1 minus sine squared theta for this cos squared theta right there, 5 sine squared theta over 1 minus sine squared theta. So we just left with simplifying the numerator now, right? So this will be 3 sine squared theta plus 5 sine squared theta minus 5 sine to the power 4 of theta, or this is over 1 minus sine squared theta, right? So this will give us 8 sine squared theta minus 5 sine to the power 4 theta over 1 minus sine squared theta, like this. And we can see that this is identical to that, so we have shown, right? And our part B is saying hence solve the equation this is equals to 9 for that. and we see this way again. So it means we're going to get something from the previous question, right? Be it the answer or the question, we're not sure yet. But looking at this, we can see that it's, wait, let's check. It is part of this, right? 3 tan squared theta plus 5 sine squared theta. We have it there. It's what we have right here. And we know that this can also be written as this in terms of sine. And this is better to work with because we only have sine, right? And not a combination of sine and tan. So in place of this, we're going to write this. So 8 sine squared theta minus 5 sine to the power 4 theta over 1 minus sine squared theta. Did I get that right? Yes. Is equal to 9. Cross multiplying this, we get 8 sine squared theta minus 5 sine to the power 4 theta being equal to 9 minus 9 sine squared theta, like that, right? So we're going to go ahead and take everything to the right hand side. 5 sine to the power 4 theta, then we have minus 9 sine squared theta minus 8, so that will be minus 17 sine squared theta plus 9 being equal to 0, right? And we can see that this now looks like a disguised quadratic equation because we can see that this power is double this one, right? So we can go ahead and say let y be sine squared theta, like that, right? So we can rewrite it as 5y squared minus 17y plus 9 is equal to 0, right? And to get y, we're going to try and use the quadratic formula, right? So our minus b, we have 17 plus or minus 17 squared minus 4a, and our c, 9 over 2a, that's 2 times 5, 10, right? So this is supposed to give us two values of y. The first one being 17 plus root of 17 squared minus 4, 5, 9 over 10. Oops. And that's 2.744. And the other one, now using the minus, 17 minus that, so the 0.656, right? So these are the two values of what? Of y. But we know that y is standing in for sine squared. So we're going to replace y with sine squared. Sine squared theta is equal to 2.744 or 0.65, let's use the calculator for 1, 65597, right? Now with this, to get theta, we know we first have to square both sides, right? So that we can have sine theta being equal to plus or minus root of 2.744 or plus or minus root of 0.65597, like this, right? So our theta will be sine inverse, first answer will be plus, so we just write it as this. So you know the first answer is sine inverse of positive this, and the second one will be sine inverse of the negative that. And for this one as well, like this, right? and we're given a range there, right? So let's just punch these and see what we get, right? Arcsine root of 2.744. So this is giving us an error. Let's try the other one. So we're just going to kind of like ignore this negative, use the positive one. So that will be arcsine root of 7.65597. It's giving us 54.09, which is 54.1 degrees, right? So this is our principal value right here, right? So principal value like that, and we know we're going from 0 through to 270. So using our cast diagram, that's the only reason why we ignored the negative sign, just because we wanted to use the cast diagram. But if we're using the graphical method, we're going to consider that there and there. So with this, we know for the first quadrant, that will be our PV. This will be our 180 minus our PV, our 180 plus our PV, then our 360 minus our PV, right? And so writing all the answers down, our PV we have already written. Our answer for the second quadrant is 180 minus that. So that's 125.9 degrees, and our 180 plus PV, that's our 234.1 degrees. Then 360 minus our PV is giving us 305 and 9 over 10, like that, 305.9. Right? So these are the four answers that we have, right? But now we have to look at this given range of theta, right? We're only taking values between 0 and 270, and the only values that are between 0 and 270 are this PV, this one, and this one. So we discard this and we take these three to be our answers. Then you get your 4 marks for that, right? And for number 8 now, it's saying a geometric progression is such that its second term is minus 120 and its sum to infinity is 160. And part A is saying find the common ratio, right? So we know that for any term in a GP, it's AR to the power n minus 1, right? And here we're being told that it's the second term that we're dealing with. So that's 2 for n. So AR to the power 2 minus 1 is minus 120, right? So this is AR is minus 120. And we're also told that the sum to infinity is 160. And we know sum to infinity is A over 1 minus R, right? So we write it as A over 1 minus R is 160. Then we solve these two simultaneously, right, to get R. So making A the subject here in the first equation, you can see that A is minus 120 over R, and for this one A is equal to 161 minus R, like that. And so A is always equal to A, so minus 120 over R should be equal to 160 minus 160R, right? And to clear off this fraction, we're going to multiply everything by R, right? So that will be minus 120 for that. Then this will be 160R because we're multiplying everything, and that will be 160R squared, like that, right? So taking everything to the right hand side, we get 160R squared, to the left hand side rather, minus 160R minus 120 is equal to 0, right? In solving that using our quadratic formula, that will be 160 plus or minus root of 160 squared minus 4. Our a 160, then our c is minus 120 over 2a, like this. And this gives us 160 plus root of 160 squared minus 4, 160 minus 120 over this, right? It's giving us 1.5, right? Because we know that r has to be less than 1 for this to be true, right? So this is the only value that's less than 1 in this case. So r is minus half. So we discard this one, right? And for part B, the first 9 terms of the progression are now removed, right? Find the sum to infinity of the remaining terms of the progression, right? Find the sum to infinity of the remaining terms of the progression. We're removing the first 9. So it means for this new progression that we have, a is the 10th term of the first. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth. Let's get to 10, right? And we're removing the first 9, right? That means this is now our a, right? Then this will be our second term, third term going forward, right? So we're going to try and get the 10th term of the first progression, right? When we had the 9 terms. So that's ar to the power 10 minus 1. So that's ar to the power 9. And our a from here, a is 120 minus 120 over r. So a is minus 120 over r, which is this. That's 240. A is 240. So we're having 240, r is minus half to the power 9. So that should be 240 minus half to the power 9. That's giving me minus 15 over 32, right, as my 10th term. And this will be our new a, right? And the 11th term will be a, which is our 240, our r minus half to the power 10, the next one, right? And that will be 240 minus half to the power 10, and that is giving us 15 over 64, right? And to get the common ratio of the new progression after removing the 9 terms, we're going to say the second over a. So that's our 15 over 64 being divided by minus 15 over 32, right? And this is going to give us 15 over 32 minus a half is still the same. Oops, my bad. It's still the same. So the sum to infinity will be a over 1 minus r, right? Our a now is this. I'm going to use this one because we're starting from the 10th going forward, the remaining ones, right, after removing 9. So that's minus 15 over 32. So we didn't have to do this since r is the same, r is constant throughout, right? Over 1 minus our r is minus half, like that. So that's minus 15 over 32, 1 plus half, right? Minus 15 over 32 over 3 over 2. And that gives us minus 5 over 16 as the sum to infinity of the remaining terms of the progression. Alright. And for number 9, we're told that a curve is such that its second derivative is 6 over x to the power 4 minus 5 over x to the power 3. And it is given that the curve has a stationary point at half 9 and part A is saying use the expression for the second derivative to determine whether the stationary point is a maximum or a minimum, right? For 2 marks, right? So we're just going to substitute this x value of the stationary point in here, right? If we get a value that is greater than 0, we say it's a minimum, right? And if we get a value that's less than 0, we say it's a maximum, right? So substituting half in there, we get 6 over 0.5 to the power 4 minus 5 over 0.5 to the power 3. We get 56, and 56 is definitely greater than 0, so it's a minimum, right? It is a minimum. And B is saying find the equation of the curve for 7 marks, right? So let's map out what we're going to do, right, for these 7 marks. We're going to use integration. That's a bit obvious. So we're going to integrate twice, because we know that if we integrate once, we'll get dy dx, and we have to integrate again. But we have to keep in mind that we have c, the constant, after each integration, right? So we need to be careful with that. So we're going to use this as 6x to the power minus 4, right, minus 5x to the power minus 3, like this, as the expression for the second derivative, right? So integrating this, we know we're adding 1 to the power of x and dividing by the new power. So this is 6x to the power minus 3, and we divide by the new power, minus 5x to the power minus 2 divided by the new power, plus our constant. This is now dy dx, the first derivative, right? The reverse of differentiation, right? 0 is equal to minus 6 plus c, right? And our c will be 6. So dy dx will be minus 2x to the power minus 3 plus 5 over 2x to the power minus 2 plus 6, right? And we're going to integrate this one last time to get the equation, right? So we're adding 1 to the power and dividing by the new power. So this will be x to the power minus 1, then we divide by minus 1 plus 6x. Then we introduce another constant. Let's call it r, right? And to get this last constant, we are going to use this point, right? This. We know that it's a point on the curve. So when x is half, y is 9, right? So y is 9 when x is half. So this will cancel out. Then we say half. Then minus 5 over 2 half minus 1 plus 6 half plus r. And this will give us r to be 9 minus 0.5 to the power minus 2 plus 5 over 2 to the power of, like that, to the power minus 1 minus 3, minus 3, and r is 7. So the equation will be y is equal to x to the power minus 2 minus 5 over 2x plus 6x plus 7, right? You get your 7 marks for that. And now on to number 10, which is saying the diagram shows the curve with equation that for values of x such that they're going from 0 to 7, the tangent to the curve at the point P, which is a 7, 0, meets the y-axis at the point Q, is right here, and region A is bounded by the curve and the two axes, x and y, and the region B is bounded by the curve, the line segments, and the y-axis. Right, and it goes on to say find the area of region A. Right, find the area of region A. So this is us being asked to find the area under a curve. Right, and for that we know we need limits. So we're going to use these points to get our limits. Right, and so we know that our point O here is 0, 0, and we're told in the equation that P is 7, 0, right, like this. So we're just going to focus on the x coordinates of these 2 points, and we're going to use them as our limits. So our limits will be from 0 to 7, right, and to get that area we're just going to integrate this with respect to x. So that will be integral 4 3x plus 4 to the power half minus 2x minus 6 dx with respect to x, right? And integrating this, we write it as it is, then we add 1 to the power, that will be 3 over 2, then we divide by the new power and multiply by the derivative of the bracket, which is this part. So if we differentiate this part, this 3x plus 4, we get 3. So that will be the derivative of the bracket that we divide with here, right? So after doing that, for minus 2x, it will be minus 2x, adding 1 to the power 2, dividing by the new power. Then this will be 6x, right? And this, simplifying this a bit further, we get 4 3x plus 4 to the power 3 over 2 over, that's 3 times 3, 9 over 2. You can write it as 4, 5 minus our x squared minus 6x, right? And then we introduce our limits, 0 and 7. So substituting 0 in there, that's 421 plus 4 to the power 3 over 2 divided by 4,5 minus 49 minus 42. That's 20 and 1 over 9, right? And substituting 0, we can see that this will be 0 and this will also be 0. And if we put 0 in here, this will be 0. So we'll be left with 4 in brackets 4 to the power 3 over 2 divided by 4,5. Wait, 4 to the power 3 over 2 divided by 4,5. That is giving us 7 and a ninth, right? Subtracting this, we get 13 square units, right, for the area of A, right? And moving on to part B, it says find the area of region B, right? And looking at our diagram, region B is this one, right? So we can get that by saying area of this triangle minus area of A that we've just calculated, right? But to get the area of that triangle, we would need the coordinates of Q, right? So that we know the height here, because the base we already have is 7, right? 7 units, right? But we'll need the height, and so to get that, we need the equation of this line. And to get the equation of that line, we're going to use the fact that it is a tangent to the curve at P. So we're going to differentiate this and get dy over dx, right? And with that, we're going to substitute 7 because it is the x coordinate of P, right? And by that, we're going to get the gradient of the curve at P, and we know that it will be the same for that of the line, right? Then we use that gradient and this to get the equation of QP, right? And we take the y-intercept to be the y-coordinate here, right? And we use this and this to get the area of the triangle, right? So let's go ahead and do that. So let's just do it here. So differentiating that now, we say we take the power down, multiply by 4, then we multiply by the derivative of the bracket again. So when you're differentiating, we multiply, right? 3x plus 4 to the power, then you subtract 1 from the power, so it will be minus half. Then that will give us minus 2. And differentiating a constant will give us 0, right? So this is what we get. And simplifying it, we get 3x plus 4 to the power minus half minus 2 as our expression for dy dx, right? And substituting 7, we get 6, that's 21 plus 4 to the power minus a half minus 2. We're getting m to be minus 4 over 5, right? So using that value of m and point P, we can get the equation of the line, right? So equation of line QP, we say m is equal to minus 4 over 5 and P is 7, 0, right? So going to use y minus y1, which is equal to m x minus x1, right? So y minus this y part, 0, being equal to m, which is our minus 4 over 5, x minus 7. Y is equal to minus 4 over 5x plus 28 over 5. And we can see that this is in the form y equals mx plus c, right? And we can see that this is our y-intercept. So that's the y-coordinate of Q, 28 over 5. So Q is 0, 28 over 5, like that. So our height here, in other words, is 28 over 5, because we're going from 0 to that. So to get the area, we just say base times height over 2, right? Our base is 7, remember. So area of triangle is equal to half base times height, which is half our base 7 times our height 28 over 5, and this comes down to be 28 over 5, 19 and 3 over 5 square units, right? And to get area of region B, remember we're saying area of the triangle minus area of region A. So area of A is 13, so going to subtract that from here. So it's 19 3 over 5 minus 13, right? Then we get our 6 and 3 over 5 square units as the area of region B. Then we get our 5 marks for that, right? moving on to number 11. It's saying functions f and g are defined for all real values of x by f of x equal to 4x squared minus c, and g of x being equal to 2x plus k, where c and k are positive constants. And it is given that the inverse of g 3k plus 1 is equal to c, right? And part A is saying show that g f of x is equal to 8x squared minus k minus 1, right? And to get g f of x, right, just us substituting the x part in g of x with f of x, right? So this x part, we're replacing it with f of x, right? So g, let me write it like g f of x will be equal to 2. In place of x, we're putting 4x squared minus c, which is our f of x, plus k. And this will come down to be 8x squared minus 2c plus k, right? But if we look at this, we do not have a c. So we're going to try and get this c off the expression. This is g f of x. And we can see that we have a c here. And we're told it is the inverse of g 3k plus 1, right? And so for that, we're going to try and get the inverse of g of x first, right? You know g of x is 2x plus k, right? So if we can write this as our y, it will be equal to 2x plus k, right? Then we swap the x and y around. So this will be our x, this will be our y, and this will be our k. And we make this y the subject of formula. So x minus k over 2 will be equal to our y, and this will be the inverse, right? It's equal to x minus k over 2, like this, right? And we're told g to the power minus 1 3k plus 1 is equal to c. So we're going to replace this x with this in here, right? So the inverse of g 3k plus 1 is us replacing x in here with 3k plus 1. So 3k plus 1 minus k over 2. So our inverse of g 3k plus 1 will be equal to 2k plus 1 over 2, which is just k plus a half. And we're told this is c. So we're just going to replace the c with k plus a half there for this part, right? So 8x squared minus 2c plus k will be 8x squared minus 2k plus a half plus k. And this will be 8x squared minus 2k minus 1 plus k. And this will simplify to 8x squared minus 2k, okay, minus 2k plus k will give us minus k minus 1, right? And we've shown that f g f of x is 8x squared minus k minus 1, right, for 4 marks. And for part B, it's saying the curve with equation y equals 8x squared minus k minus 1 is transformed to the curve with equation y equals h of x, by the following sequence of transformations. And the first one being a translation of vector 2, 3, followed by a stretch in the y direction by scale factor k, which is followed by a reflection in the x-axis, right? Then the question says find an expression for h of x in terms of x and k, right? So we have y is equal to 8x squared minus k minus 1, right? And so applying the first transformation, which is a translation in the horizontal axis, if it's positive like that, if the vector is showing a positive number, for example this one is saying plus 2, we write it in the equation as a negative, and we know it will only be affecting the x part. So it will be y is equal to 8x minus 2, because it's plus 2 in the vector there, squared minus k minus 1, right? And applying the other translation, which is in the vertical axis, just be saying y is equal to 8x minus 2 squared minus k minus 1, then plus 3. This one we write it as it is, and this will be 8x minus 2 squared minus k plus 2, like this, right? And now applying the stretch in the y direction by scale factor k, just us multiplying everything by k, right? Because stretch in the y direction is a stretch of the whole equation, right? So that's k multiplying everything. That will give us 8k x minus 2 squared minus k squared plus 2k, like that, right? And lastly, applying the reflection in the x-axis, just us multiplying everything by minus 1 again, right? Minus 1. So if we multiply everything by a minus 1, get minus 8k x minus 2 squared plus our k squared minus 2k, like that. And this will be our h of x after the 3 transformations, right? And for part C now, it's saying the range of h is given by h of x less than or equal to 15, and it says find the values of c and k, right? So for this one now, we need to understand that if we were to show or if we were to sketch this, right, we would want the turning point and we write it as this and this, right? So it will be minus this, which will be 2, and the y coordinate will be k squared minus 2k, like this. So this will be what? The coordinate of the turning point, right? And looking at our equation, we can see that the coefficient of x squared was positive, so it will be the coefficient of x squared was positive. Oops, it's negative now, right? So it's now facing down because it's negative, so we're referring to h of x. So it will be looking like this, right? And this will be our point 2k squared minus 2k, right? And whenever we're dealing with range, we're mainly focusing on the y-axis, so we're dealing with the y coordinate, right? And we're told that the range is given by h of x, which is the whole thing, being less than or equal to 15. And we can see that if it's being less than or equal to 15, that means this highest point here should be at 15, right, or less, right? So we can safely say our k squared, which is our y coordinate, is equal to 15, right? In solving this, we get k squared minus 2k minus 15 is equal to 0, right? And from here we can use a quadratic formula. So k will be equal to 2 plus or minus root of 2 squared minus 4 minus 15 over 2, and that will give us 2 plus root of 4 minus 4 minus 15 over 2, 5, or the other value is minus 3, right? But if we go back to the question up here, it says c and k are positive constants, meaning c and k cannot be negative, right? So we're going to take k to be 5. We're going to discard this one, right? And to get c now, if we look at this part of the question, it said c is equal to k plus a half, and we now know that k is 5, so c is 5 plus a half, which will give us 5 and a half. So c will be equal to 5 plus a half, which comes down to be 5 and a half, like this, right? And that brings us to the end of this paper. And if you find this video useful, please do consider subscribing to my channel for more videos.